Okay, well, it's a very different conference from I'm used to attending. For the last 15 years, I've run a healthcare IT company. We specialize in integration, so I'm used to sort of going to conferences where people wear suits and ties. I dress down, but obviously I need to kind of go in sneakers tomorrow. Yeah, we have a bit of a different application of Lua to a completely different application to what people normally do in terms of a vertical that's removed from what a lot of you would deal with. So I'm the CEO of INTERFACEWARE. We make an integration engine in healthcare called Iguana. I have a bit of an unusual role in the sense that I do most of my work as development and so on. So I actually was involved in the development of the engine. So what do? We do integration in healthcare. We use Lua to power the latest version of our integration engine. We sponsor the Lua JIT project. And the technology that I'm going to be showing today is actually something that is pretty much the core of our business. It's something that we were installed in well over 10,000 sites. We have over 600 direct customers ranging from Xerox, G Medical, Fuji. So it's actually very, very practical technology for what we use it for. So what is the integration problem? It's basically every IT system that you have that's used in business, whether it's in the healthcare vertical or in other kind of areas, always, they tend to have quite large databases. There's always multiple valid ways to represent data in a database. And so when an institution buys a new application and they want to integrate that with their other applications, there's always custom development work that has to be done, whether that's done by the vendor that sells the system or by the institution which buys the system. At some point, if someone wants to share data, then custom code has to be written to share the data between different systems. And so it's a big costly problem, because somebody has to be paid. You have to actually sit down and write that code, and it's not something like a normal software project where you can amortize that cost over millions of units. It has to be done with every site. And typically, the people that do integration projects are not hardcore programmers. They're usually semi-technical. They often will have a lot of domain knowledge. In the industry that I work in, they'll come from, like, say, an ex-nursing background and so on. So they understand things like clinical workflow, but they don't come home from a day of interface programming and get on to sort of hacking Linux internals. So the technology that you have to kind of accommodate this integration work needs to be very, very simple and easy for people that are not hardcore coders. So it's the classic ETL problem, which is extracting data, transforming it, and loading it. And it's a whole class of software products which are out there. And what we did was just come up with a very, very different way to tackling that general problem. So traditional ETL software, there's a real emphasis on big graphical GUIs. You have schemas and mapping tools. And the fundamental sort of sales line is you can do all this integration and you don't need to write a single line of code. No programming required. But it's not that simple. Often, when it comes down to it, a lot of ETL software is sold on the strength of the GUI, but then people end up writing pages and pages of scripting, usually in fairly inadequate sort of programming environments, because it's impossible to avoid the programming aspect that's required to get the interfaces working between systems. So, just repeating myself there. So, historically we had an integration engine, mapping engine that was pretty much along traditional ETL lines of having a mapping GUI. You could open up little dialogues and type in a bit of Python script and so on if you needed to kind of escape the GUI. And what I observed from looking at our best customers were that they were writing just pages and pages and pages of Python script to do their integration and practically working around the mapping layer. So about 5 years ago, we started to look at the problem. Then 4 years ago, we began a project to kind of build a better scripting environment inside of our engine. We started off with, I spent a month kind of trying to get Python, figure out some better ways to interface with that. And, I was quite happy with what I'd achieved. And then one of my programmers said, look, you really got to sort of take your abstraction and try it out with another language. And they suggested Lua. So I did the same work in 2 days with Lua, and after that I forgot about Python. Lua, I've worked, many years with Python, and it's night and day compared to the cleanness and simplicity of the Lua design. The APIs are very well thought out in terms of the fact that Lua, when you're interacting with C or C++ and the Lua API, it's been very cleverly designed in the fact that you never get a reference to a Lua object. You're always pushing and popping things off the virtual stack. You're never, allowed to shoot yourself in the foot by getting a reference count wrong, which is the way that the Python API works. It's with reference counting. So it's very, very easy for one line of code to forget to decrement or increment something too much, and then you have a memory leak, and it's a very, very difficult problem to trace down. The Lua, API and the internals is just so much less complicated, and it made it a lot easier to work with. So, and it was a sort of a complete rethink of what we were doing, so it sort of seemed like a worthwhile risk to take to kind of switch languages. So, one of the key things that we were able to work with is that Etl Software is a very, very specialized kind of programming. It's algorithmically, you're not dealing with very complicated algorithms. It's not, programming, wizardry. You have data comes in, you have to transform the data, it goes out, and it all happens in a fraction of a second. And so because of that, we're dealing with a much smaller use case than people that build IDEs for much more general sort of purpose, for general software development. And if you look at, the IDEs which are out there, people usually, they can't assume that the software can only run for a really short time. They, usually want to support multiple languages. In our case, we weren't trying to build an IDE for general software development. We were trying to build, to tackle a very, very specific sort of problem, which is what, the purpose of our company is. So, because we have a limited scope of what we're building for, I was interested to sort of hear the comment earlier, looking at, text editor design, builder, completion. We were able to kind of take the approach where we actually execute every time the code is changed or auto-completion is invoked. We actually do execute the whole script from start to finish, or at least up to the point where the cursor is. And we can do that because of the limited use case that we're targeting with our software. So, we basically are able to kind of know exactly what the type of the object we're looking at. We know exactly what data comes in, what data goes out, because we can run the entire transformation from start to finish. I mean, it's the beauty of ETL software. It's a very linear start to finish. It's like, doing mainframe batch processing, as opposed to sort of doing full-out application development. And so, the way that the IDE works is that we collect all the information from the debug APIs and then graphically render that inside the GUI alongside the code as the developer is using the environment. Basic sort of foundation, it's a web-based IDE, so that's really, really convenient from this perspective that usually an interface engine sits in a corner on a server somewhere and nobody really looks at it once it's been set up. And so if it goes bung, then it's nice to be able to just open up a browser on any computer, log in, and actually look at the code inside a web-based environment. We use C++ in the back end, which is why the choice of Lua was a very easy one, because it's very easy to interface with Lua. We use CodeMirror for the base of the editor. It's a very, very popular editor. I think quite a lot of editors like Cloud9, I think, use that as a sort of a base platform. No? Oh, okay. Oh, well. Sorry, I thought you did. Never mind. But yeah, there's a lot of projects which use it. It basically does a colorized editor and so on, and then we're able to kind of build all the sort of stuff that we do on top of it. Yeah, we use jQuery, a lot of JavaScript, obviously, because it's for all the web sort of base side. And the editor is built in a sort of a client-server approach, where we basically treat the browser as a client written in JavaScript, which is talking to the server using JSON as the means of communication. So best way to really kind of get a feel for it is to actually see the thing in action. So I've got a project which I can just open, just kind of give a bit of a feel for what the environment's like. So I'll just log in. Okay. There we go. Okay, so this is the editor. So top of the thing, you'll notice we have a sample data sort of piece here, which is critical. With ETL programming, you're dealing with messages. In the case of like the healthcare vertical, the protocol we deal with a lot is called HL7. So this is this sort of hat and bar kind of delimiter format that you can see here. We have a sort of a video recorder interface that allows you to sort of cycle through various messages that you're testing through the code. So basically, as I said, we take in the main function. We've got the data here, and then we can type in code, and so you can sort of see we've got like HL7 parsing functions here. I can pick the parse function. Things like context-sensitive help are really well developed in terms of, we know exactly what we're dealing with, so we've built up the frameworks and so on to kind of make it easy to kind of give good help on the functions. So I can go and put in things. The IntelliSense supports knowledge of the parameters that these functions sort of take. It's basically all done. We build up a sort of a help. We describe the help using a Lua table syntax and so on. So it knows the function I'm looking at, and then it's able to look up the help information, which is stored in a Lua table. So I can put in VMD, which is the schema that I'm dealing with, and then I'll go data. So I type in the data. And you'll notice that the IntelliSense here is, unlike a conventional IDE, which usually just puts grammatical information about the objects that you're looking at, because we're executing the actual code and we're putting real sample data through it, we actually get the information on the values of the variables, not just the grammar. And that's, obviously this is not a way that you'd want to develop most normal software, but for ETL software, this is really, really useful because you are essentially hacking apart data and dealing with the real use cases and so on that you're doing on an integration. So I'll just complete that. So, we can, the IDE supports navigation, much the way that a normal IDE supports it. Although the mechanism is a bit different in the sense that we're dealing with a call stack. So if I call a function 10 times, I can navigate to whatever call that I made. So if I click on here, jump to here, if I go to sort of like next of kin, I'll map to fifth call. And you can sort of see I'm mapping to the fifth call of calling that function, which is in a loop. So it's very, very handy for debugging, because if you get, like a helper function which is called 100 times, in a traditional debugger, you would need to put a breakpoint at the point until you find the point where it breaks. Here, it's just easy to jump to the 97th time where you had about edge case which breaks it. You can jump back to the exact line of code which called it the 97th time, etc. It's certainly not an approach which would work for developing every type of software. Like if you're running, something that's running for more than a few seconds, this becomes a bit cumbersome. But for ETL software, it's a very, very effective way of debugging the transformation logic you deal with in this area. So I can, I'll go back to, all right, so You can sort of see here we've got just an example of dealing with an XML document. So x equals XML. Data. So the template is just it's filling up a little Lua string, which is defined just a blank string with some XML in it. We produce that XML object, and then I can go and populate it. So, and yeah, we had a bit of fun experimenting with some of the ideas with auto-completion in this environment. Because you're dealing with trees of data, traditional auto-completion, which tends to be just single level, where you're going down one level at a time, would actually be very inconvenient in this kind of application, because you really want to kind of just, go down multiple steps. So in this case, I'm pulling out the name of a patient, like, going for first name. Oops. Like that. Or I don't have to just sort of search on the actual grammar. I can also go for searching on the content of the data, which once again is different to a conventional IDE, but it's very much driven by the use case of using this as a way of driving a middleware ETL engine. So I can go put that there. And you can sort of see as I'll just, hard to see on the big screen there. If I flip through the sample cases, you can sort of see, the data going through the engine, the mapping, and what's sort of applied. So it's very, very, very convenient for the integration engineer that sort of needs to test out various messages and sort of see how they go. In a traditional ETL engine, you do the mapping sort of side of things, and then for doing data transformations like capitalization and all that sort of stuff, you'd have to jump off to a separate tool or open up a functoid or some kind of graphical metaphor. Because we've sort of got this IDE, which is really, really well specialized on, providing like a mapping view, you don't need to make that jump to a different environment to do data transformation. So you can sort of see here, like, I can click on the capitalize function, and you can actually sort of see the implementation of that function. So I've got like Mary, first letter, pulling it out, and returning, back to the output. We can deal with loops. When we deal with loops, we create these sort of sub-annotation blocks which have a little navigation control. So you can look at, the number of times if I go to a different message that hasn't got the next of kin there. You can sort of see that, how many times it gets called. And I can jump into, the next of kin sort of piece. It's really, really convenient for, doing this kind of data transformation work and so on, because it's just, you can actually get in there and just type it out on the fly. Like I can just go in and so you can sort of see it's very, very, very quick and simple to just kind of rip through the data. Anyway, a lot of sort of times people need to do things like like in radiology, for instance, a lot of radiology information centers will need to kind of send out emails to physicians that they have a patient and so on. So it's very easy for them to kind of rip that information out of HL7 messages in this case, and then format emails and send them off, etc. So we can do things like deal with just about, because once you've got this environment, it becomes very trivial to sort of plug in different kinds of parsers and so on, which is, it's a big improvement over traditional ETL software, which I often call consultingware, where you basically, an ETL company gets formed where they make a module for this, they make a module for that. It's really nothing very coherent to the whole thing. It's not very unified. So if we look sort of database calls, we can do queries, and it's the same sort of kind of syntax where you're basically making calls or in this case, we're returning data live. So we've got the actual live data coming back from a query, and you can manipulate it just the same way as if it was coming out of XML or document or something. So I can go kin, first name, etc. And it's very, very easy to kind of map data from a database into a message, XML message, or HL7 message, and so on. Sometimes this sort of thing is useful too if you've got, oftentimes in healthcare, companies go through acquisition cycles where they'll buy, they'll have like a EMR, electronic medical record system, and they'll buy a radiology information system. And so they have these two essentially different products, and they want to make them look like they're one. And so somebody would have to kind of write code to kind of take stuff out of one database and sync it up in the other one. It's quite useful for that sort of thing because you can, easily sync up quickly without having to go through some of the industry standards, which can be quite cumbersome, like HL7. So you have, that kind of, the database interface. Doing, web services is quite easy. You just sort of, you can make calls out to, I've got an example here. We're not, we wouldn't win any prizes for the efficiency of the platform. That's not really our target, but it's really all about ease of use and getting this code done quickly within, because everything's a fixed cost project. But you can sort of see here, we do a post to a web service, putting in that, getting back some JSON as a result. And it's a very easy to discover kind of API. Like if I type in .NET, I'm getting all of the protocols. I can, I've got all my different HTTP transactions and so on. Flipping it around, if I look at what we're actually doing here is sort of posting to this channel itself. So if I go to the HTTP receiver sort of side of things, you can sort of see how it fits with taking in the web transaction. So if I go to Lua, source, and so here we've got like an HTTP transaction coming in that came in from the other channel. You can sort of see it's got the payload of the XML, and it's just the same deal, really, just ripping apart the data using the parser built in here. So I sort of take R net parse request data. That gives us our object with all of the body and so on, and then we can just parse it and manipulate it just the same way as we were in the other instance. So one other interesting sort of application of this is often what's sort of happening in the healthcare industry is that you get a lot of pressure on vendors to sort of classic pressure that a lot of vendors have when they have an information system they sell to hospitals and so on. It's a negotiation process that often happens between the hospital and the vendor. And the hospital says, we're big, we're the Mayo Clinic, we have our specific workflow, etc. We want you to add XYZ feature to your system, etc. And so a constant pressure that the vendors all sort of have is that they have all these sort of people asking for lots of features that are specific to how specific customers work. And so the average IT system in healthcare ends up looking pretty ugly by the time you've patched on all these different features. And the trend that people are moving towards, the smarter vendors, are that they're sort of figuring out that if they can actually break up their application to the point where they have like a RESTful web service API which allows sort of invocation of certain events in their application, then it means that the field deployment people, the integration engineers, can actually go in and take arbitrary data and then create arbitrary workflow in the application. So like if you've got like an electronic medical record, they could add a patient, they could delete a patient, they can add a next of kin, they can create an order, they can add an allergy or do any number of business events. One of the challenges, of course, is just that the APIs for these things end up being quite big because you're dealing with a whole load of very domain-specific information. I don't know how many people here have dealt with electronic medical records? One, okay. Two. They tend to be pretty big, like a typical EMR will have at least 100 tables in it and so on. So one of the things that we tried to do is actually sort of provide a good foundation to make it easy for people to actually build out a user-friendly API that could be used to actually manipulate this. That would be easy for the field deployment staff who, if we remember, are not super technical to quickly learn and be productive with. So we're able to leverage the environment to do that by using this approach where we build up sort of hierarchical libraries, and Lua lends itself beautifully to this. So I can type in like EMR, and I've got all of my different functions and so on. But you can imagine in a real EMR, there'd be sort of like 10 groups of functions, and each of those functions would have like 4 or 5 operations. So you end up with a total API of maybe 200 functions. Because this environment supports that sort of deep IntelliSense sort of feature where you can kind of drill down deep into the all of the children, it's really easy to kind of build up that kind of API. So I can type in patient, add, and it prompts me in terms of the actual parameters that function sort of does, takes, and also, you can build in like the help information so that it's very easy to sort of describe to the field tech exactly what the function does and make it very, very easy to use. We drive that through a fairly minimalist sort of Lua solution. So it's basically, if we look at the module, we've just built up a hierarchical table with sub-libraries. And the help format is just expressed as a Lua table. So you can sort of see you've got things like if it's, we say true if it takes a parameter table, and then we have a table of named parameters. And that's what we're powering the IntelliSense off. Initial sort of versions of the translator, a lot of the code was sort of written in C++ in the back end. But as we've been moving forward, we've started to write more of the back-end code in Lua itself. Like this extension help system is completely written in Lua. But, it just makes it easy to kind of add in that help system that kind of makes it simple for our end users to actually build out APIs that fit nicely with their systems. So in terms of, what are the future directions and some of the challenges, because we, are executing the data live, it means that most of the APIs that we deal with in this environment need sandboxing in terms of the fact that we have, the ability to map into a table, and then we have like a DB merge function. But the DB merge function by default doesn't run when you're in the editor, otherwise you'd be constantly inserting data into a live database, which would be undesirable. This is sort of one of the trade-offs that we had to make. Nothing comes for free, there are no free lunches. But it's basically, so what a lot of times we do, a lot of the API functions, we have like a live flag, which allows the user to sort of toggle off whether or not a command is actually executed when it's in the editor. So that's one of the challenges. Some of the, while we were developing the early betas, used to sort of transfer just megabytes and megabytes of JSON data between the browser and the server. So we had to make some compromises and design choices in terms of just how much JSON, how much data we would sort of, project out to the browser, which is one of the more interesting challenges. I mean, it's surprising what you can do with a modern web browser and so on. I mean, it's just really a matter of just treating it as a client program written in JavaScript and then if you're doing any kind of client-server programming, you just want to be careful about how much data you send between the client and the server. What's next? We're in the process of doing the next iteration of Iguana. We've codenamed it Tuatara inside, which I think nobody that's outside of New Zealand has ever heard of. I'm originally from New Zealand, but it's an obscure New Zealand lizard. But Tuatara is really just redoing everything else but the translator, sort of just looking at making it so that we can distribute across multiple machines and just have a more flexible architecture in terms of the queuing inside of it. One thing we have toyed with internally, obviously making IDEs isn't really a core focus of our company. That's not what we're here for, but we have, we're sort of curious to sort of see whether there's any interest in us just spinning off a free version of the translator. I mean, it's quite useful if you're rattling off a quick script and you just want to kind of, test the functionality and so on. Some of the things we're looking at leveraging as we upgrade to the LuaJIT 2 is just sort of taking advantage of some of the FFI library bindings and so on. I think that could probably be quite useful for us because we could get some performance benefits. There's obviously a lot of to and fro C++ and Lua in the way that we've implemented with, because all of our HL7 parsing libraries are in C++. The other idea that we've been toying with is just sort of actually going full way and writing our parsing code completely in Lua just to avoid the performance hit that you take going across the language boundary. We're obviously, as with Tuatara, we're hoping to look at integration in other markets and so on, but a lot of the business challenge with integration is that for middleware, you really have to position things very well. It's about, explaining to a radiology information service that they could reduce 4% on their billable stuff if they, merged the information that they have coming out of the billing report with their patient data and so on. So it's one of the interesting challenges of selling middleware. You really have to kind of tie it back to something measurable, a benefit that a decision maker can see. Backward compatibility is key. I'm always a bit scared that Lua is going to have like some really radical changes in terms of compatibility. The simple fact is that we don't control the code that our customers write, and what happens in integration work is that the hospital pays $10,000 or whatever to get the integration done. They're not going to pay another $10,000 to have it refactored to use the latest version of XYZ technology. So I'm just praying that we've made a good decision and and that Lua compatibility won't be changing too much. Otherwise, we'll be forced to just kind of freeze ourselves on a given version of the 5.1 version of Lua. But it's been quite interesting. I mean, when we brought this technology to market about 3 years ago, and I was pretty worried that we were going to get a complete rejection from our customer base. I mean, it's quite a challenging concept to sort of sell in a market which traditionally sort of sells people on the idea of not programming. Here's a tool that puts programming at the center of what you're doing, but we've made it easy. But we've been pleasantly surprised with the success that we've had with this. I think one of the best success stories I think we had was with Xerox, where they're converting from a legacy integration product called eGate. And one of their consultants basically started off in the morning without getting a demo or contacting our support desk. She basically converted 4 interfaces in the space of a day without any help from us. And it was just basically because she understood, she had a COBOL programming background. It was pretty easy to pick up Lua because it's a very simple language, and then the ease of use that we put on top of that. Whereas she was trying to use this sort of a click and point GUI thing from a competing sort of product and didn't complete the exercise. So it's been interesting. I think we're introducing Lua into a community that would never look at such a thing otherwise. and yeah, it's been quite fun. So, any questions? Yes.
Actually, I have two questions.
Yeah.
Question number one. So everything you said is pretty much equally applicable to, let's say, telecommunications. We have also we have huge number of legacy system going all the way back to 60s. Some of them even written in COBOL, and of course everything moves towards modern systems, both hardware-wise and software-wise, but this baggage is also with us all the time. And secondly, like there is another thing, I don't know, are you planning to have the similar approach for the GUI for the physicians or for healthcare professionals? Because from our dealing with healthcare, and we do have a large healthcare BU, actually they not only want to hook their systems, but they also want to have some way to say how and what is being displayed. And they're really picky about that. And it's very difficult, at least in our case, to, it goes back and forth. What window goes in which corner and what is displayed and what is font size and all that. So if they can just do it themselves without going every time to us, it would be a great help.
Yeah. Generally, like for the physician office market, you do occasionally, you get sort of some really technical doctors that have, gotten Fox Pro and written their own health information system, and we occasionally deal with those. It's still, if you think about it, if you're a doctor and you're going to be spending, 10 days of what could be billable time to do an interface, that's crazy money when you add it up compared to what they could be doing. So, for us, on the whole, we tend to kind of work with, probably about 60% of our customers are OEMs. That's people that have healthcare applications that embed our stuff into their applications, and then it makes their life easier to kind of service people like the doctor market, etc. I think a lot of the physician practice market is sort of tending towards software as a service, because it's just so expensive to kind of go and run a server under somebody's desk and a physician practice, etc. Probably 20% of our market is going direct to healthcare providers, but you occasionally, I guess there's sort of a physician office has to get to a certain critical mass of number of people before they have the economies of scale that can afford any kind of integration, because it still takes some time. And then, for the most part, it's easier to service that market through vendors that have applications that specialize in the end user. Any other questions? I'm just curious, out of the people here, does anyone sort of see, if you had a copy of this sitting around on your laptop, would it be useful to actually just hack out a bit of code now and then? Yeah, that's a lot of questions.
We have control modules and things where we deal with all the time. It'd be awesome to.
Yeah. Okay. Well, from our perspective, we're happy to give people just, copies of this to play around with and so on, just to kind of, Yes?
With regards to, so I guess I have a comment, but also a question wrapped in one. With regards to other markets outside of healthcare in the ETL space, are there anything specific that you guys are looking at in that area? Mainly for business reasons, we're focusing on healthcare. We were just sort of in the process of ramping up our sales team and just tackling the healthcare market. One of the fascinating things about software is that if you have a better technology in an area, the market doesn't sort of beat its way to your door. You still actually have to send out salespeople. You still have to build the relationships with the decision makers, and you better not show them an IDE. So even within our own, we do business with most of the big OEMs in the radiology space, for instance, like Philips and so on. But you still
have to have quite a good sales force to actually go and build the sort of the business relationships with the people that have the budgets and decision makers, and make sure that you're at the table when they're making a decision, because it's generally the people using it's enterprise software, right? The people that use the stuff aren't necessarily the people that write the checks and make the decisions as to what you're buying. So if you make a decision to go, like if we went off into a completely different vertical today, it probably wouldn't be great from a resource perspective from a sales and marketing, just because we need to kind of focus on
very specialized sales team for that market and so forth.
Yeah.
The reason I asked the question in the first place, I guess, is because you mentioned it in sort of the slides at the tail end of the presentation, but the immediate thought that I had, like especially looking at kind of the live editing, it's a web-based editor, but with the kind of deep IntelliSense, and the thing that you do that I like, and it makes sense in your context, is having sample data that is essentially, either a subset of what maybe the total data size would be, a subset of rows or whatever. You have obviously some intelligence about the messaging formats you have to deal with. And then you're doing live transforms in the IDE. That's all absolutely killer to me in certain things that I want to do, right? Like, so for instance, the free version of the IDE would be amazing for me in terms of ramping up on a project where I want to do ETL type stuff, but it has nothing to do with healthcare. I have my own message formats. I have a bunch of it's the same stuff. It's just a different domain.
Right.
The most concrete example I can give is there's a open source, it's ETL, but it's not really built as such, tool called Google Refine. It used to be called Freebase Refine. It's essentially an open source tool. It's all written in Java. It's web-based.
Right.
You run it locally on your server, and you just can dump data into it, and it gives you sort of a spreadsheet-esque kind of view. But they have 3 different languages that you can write kind of more complex transformations in, right? One is Python. One, I think, is Groovy or JRuby. And one is essentially their kind of sugared syntax on top of Python called GREL, Google Refine Expression Language. It's horrible. It's not horrible, but if I'm doing the same thing you're doing in that I'm trying to give this tool to people who have to transform, in my case, book data. So it's data about publications and books in these very weird, old, archaic formats into things that are like, I can upload to online booksellers like Amazon and so forth, right?
Okay. Right.
And trying to put this tool in front of people and say, here, extract all these, these like linear record formats, and then translate them into, column separated value data or whatever else.
Right.
And giving them Google Refine, if they can do it graphically, they can do it. But if it's anything more complicated where you have to write some syntax to do it, the syntax doesn't necessarily make sense to them. And there's no way to see the transformation in real time.
Yeah.
I can do it, and then I can roll back one step, but I can't actually see what's happening when I'm doing it.
Yeah, it's a traditional ETL tool.
Exactly. So that's what I want to see, right? And there's nothing in the open, like ETL is entirely enterprise software, so there's nothing in the open source world that tackles this kind of user friendliness, but gives you the power of an actual programming language and gives you the real time update.
Yeah. Yeah. One of the motivations for coming to this is just to kind of get a picture into other industries. I've been in one vertical for 15 years, so it's interesting to kind of understand some of the other middleware translation problems that occur in different industries and so on. It seems like every middleware market there's quite a different range of solutions that people use. It just depends on each vertical has different sort of popular technologies. Any other questions? All done? Okay, thank you.